The depth table for conduit burial typically lists different depths for different conditions, including whether the conduit is encased in concrete or not. If the table specifically states that 12 inches of burial depth is required for conduit encased in concrete, and does not make an exception for roads, then that depth should be followed. However, if the specific requirements for a project are unclear, it is always best to consult with a qualified electrician or engineer to ensure compliance with all applicable codes and standards. They will be able to review the specific conditions of the project and provide the correct burial depth requirements. Electrical conduit burial depths are crucial for safety and compliance with the National Electrical Code, or NEC, and local regulations. Understanding the nuances of these requirements, especially when dealing with concrete encasement and road crossings, is important for any electrical installation. This discussion aims to clarify the general guidelines, but remember that consulting with a qualified electrician or engineer is always the best practice for project-specific applications. The NEC provides tables and guidelines specifying the minimum burial depths for electrical conduits based on several factors. These factors include the type of conduit, the voltage of the cables within the conduit, the presence of concrete encasement, and the location of the burial, such as under a road, driveway, or other areas subject to vehicular traffic. Concrete encasement generally allows for shallow burial depths compared to direct burial in soil. The concrete provides physical protection to the conduit, reducing the risk of damage from external forces, such as digging or vehicular traffic. The specific reduction in burial depth allowed by concrete encasement is detailed in the NEC tables. For example, a common requirement might be 12 inches of burial depth for conduit encased in at least 2 inches of concrete, whereas direct burial might require 24 inches or more. When a conduit runs under a road or other area subject to vehicular traffic, the NEC typically mandates a greater burial depth to ensure the conduit is adequately protected from the weight and vibration of vehicles. This is to prevent damage to the conduits and the conductors within, which could lead to electrical hazards or service interruptions. The standard depth for conduit under a road is often 24 inches or more, depending on the specific type of conduit and the voltage of the conductors. The key question is whether concrete encasement overrides the standard depth requirement for road crossings. In most cases, if the NEC table specifically states that 12 inches of burial depth is acceptable for conduit encased in concrete and does not provide an exception for road crossings, then the depth can be followed even under a road. However, this is contingent on strict adherence to the concrete encasement specifications, such as the thickness of the concrete and the type of concrete used. It is important to carefully review the specific wording of the applicable NEC table and any local amendments. Some jurisdictions may have stricter requirements that supersede the NEC recommendations. If there is any ambiguity or uncertainty, it is always best to err on the side of caution and consult with a qualified electrician or engineer. They can provide clarification based on their knowledge of the local codes and their experience with similar installations. Firstly, review the specific NEC table that applies to the installation. This table will detail the minimum burial depths for different types of conduits under various conditions. Pay close attention to any footnotes or exceptions that may apply to road crossings or concrete encasement. Secondly, verify the local codes and regulations. Local jurisdictions may have amendments to the NEC that impose stricter requirements. Contact the local electrical inspector or building department to confirm the applicable codes for the specific project location. Thirdly, ensure proper concrete encasement. If relying on concrete encasement to reduce the burial depth under a road, ensure that the concrete meets the specified requirements for thickness, strength, and type. Improper concrete encasement may void the allowance for shallow burial depths. Fourthly, consider supplemental protection. Even with concrete encasement, it may be prudent to consider additional protection measures for conduit under a road, such as using a thicker walled conduit or installing a concrete slab above the conduit for added protection. Fifthly, document the installation. Keep detailed records of the installation, including the type of conduit used, the depth of burial, the concrete encasement specifications, and any applicable code references. This documentation can be helpful for future maintenance or inspections. The type of conduit significantly influences the required burial depth. Rigid metal conduit, or RMC, and intermediate metal conduit, or IMC, are generally stronger and can withstand greater external forces compared to non-metallic conduits such as PVC. As a result, RMC and INC may be allowed shallow burial depths in some situations. The voltage of the conductors within the conduit also affects the burial depth requirements. Higher voltage systems typically require greater burial depths to provide adequate protection against electrical hazards. The NEC tables specify different burial depths based on voltage levels, such as 600 volts or less, and over 600 volts. The type of soil in which the conduit is buried can also influence the required depth. In areas with rocky or abrasive soil, a deeper burial depth may be necessary to protect the conduit from damage. Similarly, in areas subject to freezing temperatures, a deeper burial depth may be needed to prevent damage from frost heave. It is also important to consider the potential for future excavation in the area. If there is a possibility that the area may be excavated in the future for utility work or other purposes, it may be wise to bury the conduit deeper than the minimum requirement to reduce the risk of damage. When running conduit under a road, it is essential to coordinate with the local transportation authority or Department of Public Works. They may have specific requirements or permits that must be obtained before any work can be performed in the road right-of-way. They may also have specific requirements for the type of conduit, the depth of burial, and the method of installation. In some cases, they may require the use of a directional boring technique to install the conduit under the road without disturbing the road surface. This technique involves drilling a horizontal hole under the road and then pulling the conduit through the hole. It is less disruptive than open trenching, but it requires specialized equipment and expertise. When installing conduit under a road, it is also important to consider the potential for future road widening or other road improvement. If there is a possibility that the road may be widened in the future, it may be necessary to bury the conduit deeper to relocate it to avoid conflicts with the planned improvements. Communication with the local transportation authority is crucial to ensure that the conduit installation is compatible with any future road projects. Proper marking of the conduit location is also essential. After the conduit is buried, it should be marked with tracer wire or other means to allow for easy location in the future. This is particularly important for conduits that are buried under roads or other areas where excavation may be necessary. The tracer wire should be connected to a readily accessible above-ground marker such as a utility pole or a handhole. The marker should be clearly labeled to indicate the presence of the underground conduit. In addition to the NEC and local codes, there may be other industry standards or best practices that should be considered when installing conduit under roads. For example, the American Association of State Highway and Transportation Officials, or OSHTA, has guidelines for utility installations within highway rights-of-way. These guidelines may provide additional recommendations for burial depths, conduit types, and installation methods. Following these industry standards can help ensure a safe and reliable installation. The NEC provides a comprehensive framework for electrical installations, but it is not a substitute for sound engineering judgment and experience. Every project is unique, and the specific requirements may vary depending on the site conditions, the type of equipment being served, and the local codes. It is essential to carefully evaluate all of these factors and to consult with qualified professionals to ensure a safe and compliant installation. Firstly, consider the soil conditions. Different types of soil have different thermal properties and can affect the heat dissipation of the conductors within the conduit. In areas with poorly draining soil, it may be necessary to use a larger conduit or to derrick the conductors to prevent overheating. Secondly, assess the environmental factors. In areas with extreme temperatures or corrosive conditions, it may be necessary to use a special type of conduit or to provide additional protection to prevent damage. Thirdly, evaluate the load requirements. The size of the conductors within the conduit must be adequate to carry the anticipated load. It is important to consider not only the present load but also any potential future increases in load. Fourthly, determine the conduit fill. The NEC specifies the maximum allowable fill for conduits to ensure adequate ventilation and to prevent overheating. The conduit fill is the percentage of the conduit's cross-sectional area that is occupied by conductors. Fifthly, select the appropriate fittings. The fittings used to connect conduit sections must be compatible with the type of conduit being used and must be properly installed to ensure a watertight and secure connection. Sixthly, consider the grounding requirements. The conduit must be properly grounded to provide a safe path for fault current. The grounding method will depend on the type of conduit and the wiring system being used. Seventhly, plan for future maintenance. The conduit system should be designed and installed in a way that allows for easy access for future maintenance or repairs. This may involve providing access points or pillboxes at strategic locations. Eighthly, inspect the installation. Before backfilling the trench, the conduit installation should be inspected to ensure that it meets all applicable codes and standards. The inspection should be performed by a qualified electrician or electrical inspector. Ninthly, document the installation. Detailed records of the conduit installation should be kept, including the type of conduit used, the depth of burial, the location of the conduit, and any applicable code references. These records can be helpful for future maintenance or repairs. Tenthly, consider the use of ground-penetrating radar, or GPR, to locate existing underground utilities before excavating. GPR can help to avoid damaging existing utilities and can prevent costly delays and repairs. In conclusion, determining the correct conduit burial depth, especially under roads and with concrete encasement, requires careful consideration of the NEC local codes and project-specific conditions. Consulting with a qualified electrician or engineer is always the best practice to ensure a safe, compliant, and reliable electrical installation.